In this video, we're going to continue our discussion on schematics, and we're going to take yet a look at another pictorial schematic that is available for a split air conditioning system. Now, in the last one we looked at, okay, let me pull that up, our air handler was 120 volts, so we had a neutral. Okay, in this diagram that we're going to take a look at, there's a slight change. We have a 240 volt air handler, which means that we have an L1 and an L2. Basically, that's the only thing that's changed. We also still have our PSC motors, we have a contactor, and we have a thermostat. So we have three different pieces of equipment that we have to wire together. Now, the last time I started with the low voltage side, but I think in this case, well, no, I started with the line voltage side, but let's go ahead and start with the low voltage side. So let's take care of my commons first, okay? Because we know that all of my relay coils have to come back to common on my transformer, okay? Because if I don't have a common in there, it doesn't complete the circuit. We also want to make sure we never cross or we never connect together the 240 volt with the 24 volt or bad things happen. Okay, so now let's go ahead and take a look at our low voltage G terminal. Okay, so G has to come over here, and I didn't want that wire color to change, so let's put that back. Let's click off of it and give G again. Okay, so my G terminal has to come over to my indoor fan relay. Okay, because that's what powers that or energizes that. So let's make that connection. Okay, so that's my low voltage on my indoor unit other than R. Okay, so for my R terminal, and I did that again, my R terminal gets powered from the transformer and again, I sort of like trying to keep my wire schematics as straight as possible because that way they're very easy to read. Okay. So we've now powered R from my transformer primary. That is usually the only connection we have on a transformer primary unless we have accessories in the unit, and we'll talk about that in the future. Okay, so now I want to change my wire color. I'm going to go ahead and try to use a yellow. Sometimes this works, sometimes this doesn't. Hopefully you can see it. I'm going to come off my Y terminal with my yellow wire. And what I need to power from that is my compressor contacts, okay? So I want to power my contactor coil. Okay, so the only wire connection I have between the indoor unit and the outdoor unit is my common from my transformer secondary and my Y from the thermostat. For cooling, we don't use W, okay? We only use Y. So that's my low voltage connection. Looks pretty simple this way, right? So far. Okay, let's go ahead and talk about line voltage. Okay, so I'm going to go ahead and do L2 first on my air handler. Because I want to connect it into there. And I'm going to drop down a little bit. And I'm also going to connect it into my blower motor. Actually, no, I'm going to Sometimes the lines on this doesn't cooperate quite right. Okay, so that's L2. Okay, let's go ahead and deal with L1. What do I want to do? We'll do, use a purple for that. Okay, L1, I want to come here. I'm going to connect it into there. Okay, and I also need to, from L1, I need to feed my indoor fan relay. Now, when I'm wiring a pictorial, I try to find what the most obvious junction points are going to be. By what I mean a junction point is where I'm going to have a good place to join wires together. Okay, it's usually on the terminals of a component. I don't like using a ton of wire nuts, so I try to join wires together on different terminals of components. Okay, for example, I know a transformer I'm probably going to have to wire nut anyways, so I might as well make my primary wiring connections there. Okay, sometimes I'll do it on a relay coil depending on what's closest. Try to keep wire lengths as short as possible and as direct as possible with a minimum number of splices and wire nuts. Okay, so that's my air handler indoors. Okay, so let's go ahead, and again, I'm going to try to stay with the same wire colors. We're going to go ahead and connect in L1. On my condenser. Sort of important to get the contactor connected in. Okay, out of L1, I'm just going to go ahead and take it to common of both motors. It really doesn't matter because this is AC current. Okay, so to keep things neat, I'm just going to take this and do this. And I'm going to do this. Okay, both are switched. So notice L1 is switched. So because it's AC current, it really doesn't matter, and I could keep it a little neater that way. Okay, so this is my L1, or my L1. Okay, now let's go ahead and take a look at L2. And I'm going to change my Y colors here to black. Actually, we'll stay with the blue because I did that on the other side. So we'll go blue. Okay, I'm going to come down. I want to tie in my L2. Okay. I'm going to come out of T2. And just bring it over here so I have some room. Now I'm going to tie in the run side. Okay. Of my motors. Now when we look at this, we have some ohm measurements on my windings. When you look at this, can you tell which is the start winding? That's right, it's the one with the higher resistance. So my start winding goes in series with my capacitor. And again, which is my start winding? My start winding is the one with the highest resistance. So we'll do that. We'll come and tie in run. And here, I need to bring my run winding okay. So what do we have? We have a contactor controlling a PSC compressor and controlling a condenser fan. That's also PSC. Over on the left side, we have my air handler that's being controlled, but it's a 240 volt circuit again, indoor fan relay. Now, When you're working on an air handler that's a 240 volt circuit, realize that even if it's turned, even if it's not running, you have the common side, and in this case it's the blue side of the wiring on the blower motor does have power. So be extremely cautious when you're working with these. We're only switching one side of that power. Okay, where in this case we're switching L1, but that's not always the case. Okay, AC, it doesn't matter which side is on it, it just matters I have a complete circuit. So when we're looking at the ladder diagram of this, okay, this is going to be almost the identical ladder diagram to what we have. Actually, it is basically the identical ladder diagram to what we have here, except my air handler is 240 volts. Okay, so we have an air handler that's 240 volts. We're still only switching one of the IFR sides, so common is direct, and everything here is identical to what we did. We've done this schematic before. It's just looking different because my pictorial is a little bit different. So again, pictorial is laid out to what the unit exactly looks like from a wiring and a component placement perspective. The ladder schematic takes and puts that more for what we use actually for sequence of operation. This is a far easier schematic to read when you're troubleshooting than this is. Okay, so that's what we're going to do with this diagram.